mx minus ny, alright, provided mx minus ny is not equal to 0. Now again, this proof has been asked in IFoS 2010. So we'll start with this proof. Okay, so again we start with the same thing, m dx plus n dy is equal to half mx plus ny d x by x plus dy by y plus mx minus ny dx by x minus dy by y. Alright, now it is important that what should be our next move. Our next move has to be multiplying this equation thoroughly with our integrating factor, because it seems quite logical and sensible to do so. So we multiply with our integrating factor. Our integrating factor is 1 by mx minus ny. So here it is mx plus ny divided by mx minus ny, and we can write this as d ln of x by y plus this becomes 1, so this can be written as d of ln x by y. So what should be our next move? This is the question that we should be asking. This is mx plus ny, mx minus ny. Now our clue is that we have to compare this equation with this equation, because both are in the same format. So if I write m by y f1 xy is equal to n x f2 xy is equal to, say, mu, because these equations are comparable. So why I am doing it? Because I want the value of m and I want to put it here. So mx, so I will multiply. So I want the value of mx. So mx will render me, mx is equal to mu xy f1 xy. Now similarly I want value of ny. So ny is mu xy f2 xy. Now I will add these two and I will subtract these two. So it can be readily seen that when I am doing it and dividing it, this mu xy and mu xy get cancelled. So mx plus ny divided by mx minus ny gives me what? It gives me f1 xy plus f2 xy divided by f1 xy minus f2 xy. And if I call this as any function fxy, then I can replace this whole thing with fxy. Now I will do so. You can note this point, because many times students take this xy separately, or they are not able to understand this step. So you better understand this step, that what I have done, I have just added them up, and since I have divided, mu xy has got cancelled. So please make a note of this, and I am going to use this, and I am going to place this value over here. So this becomes fxy. Again I am going to play the same interpretation or the same manipulation, that suppose x can be written as e to the power log x. Similarly, I will write my xy as e to the power log xy. So this will render me f of e log xy ln xy plus d ln xy. So what I am saying that I can replace this as e ln xy as any function g ln xy. So this is half g ln xy d ln xy plus d ln x by y. Now we can very well see that this is g of t dt plus d say u. Okay, so this has again been an exact function. So the moral of the whole story in this integrating factor is that we have to multiply with integrating factor. The moment we multiply, it makes it an exact differential equation, and then we can take its primitive, that is the integral, and find the solution of differential equation. So this proof and the former proof that I have done, that is quite important for examination point of view, and no need to mug up, just follow the basic principles and common sense. You will be able to solve such kind of question even examination. Now I will proceed. If any of you have any doubt, please ask. I think everything is crystal clear to all of you. Okay, so I will proceed because of the paucity of time. We have to move quickly. Now, suppose if we are finding dou m by dou y, dou m by dou y and dou n by dou x, and they are not equal, what we are supposed to do? In that case, m dx plus n dy equal to 0. Okay, so in that case, what we will do? We will find 1 by n dou m by dou y minus dou n by dou x. If that comes as, suppose, any function of x alone, that has to be function of x. So in that case, we can argue that integrating factor has to be e to the power integral of fx dx. This is our claim. Now, this question has been asked in IS examination in 80s, and in most of the questions that is asked even in the recent time, 2019, 18, 15, whatever, all the time they are asking its application. That is, equation is not exact, use this. Or, if this has not been the case, then we have to find 1 by m dou n by dou x minus of dou m by dou y, and if it renders me a lone function of g of y, then in that case integrating factor is e to the power integral of gy dy. So either of the two you do the manipulation, but the more focus area is your application part. But that doesn't mean that they cannot ask proof, because proof have been asked in these areas. So you better derive this, and now I am going to derive this rule. Alright. Now I will start with this key point. So if I suppose this is my nodal point, I start from here. So all I am saying that I can write my dou m by dou y minus of dou n by dou x is equal to n of fx. Okay. Now this is what we have got from 1. But all the time what we do is that whatever is our differential equation, that is m dx plus n dy is equal to 0, it is not exact. So what we do, we multiply with our integrating factor. This is the common sense that we apply. So we will multiply this integrating factor here. So this becomes e to the power fx dx m dx plus e to the power fx dx and dy is equal to 0. And I call this as my new differential equation derivative m1 dx plus n1 dy is equal to 0. Now, by the virtue of this integrating factor, it is quite clear that if I take this derivative, partial derivative, that is dou m1 by dou y, that has to be equal to dou n by 1 by dou x. Here m1 is this, that is e to the power function of fx dx, and n1 is e to the power fx dx, and here m has to be multiplied. Okay. Now all we are saying that we will take the derivative of dou m1 by dou y, partial derivative. So now I keep this one whole function as constant because it is devoid of y, but m, this is written as dou m by dou y. Okay, till this point it is clear. I will now I will find dou n1 by dou x. Again I am keeping this function as constant, e to the power fx dx. Okay, this will be dou n by dou x. Alright. Now I keep n as constant and I take the derivative of this one, e to the power integral of fx dx. So we know that integration of e to the power x or ax is first integrate that only. So we will write this as e to the power fx dx. Now again we have to differentiate this argument. So what is the differentiation of integration? That cancel out, so only we are left with this function fx. Okay. Now I am going to plug the value of nfx here. So this becomes nfx is how much? Dou m by dou y minus dou n by dou x, e to the power fx dx. This is e to the power fx dou n by dou x. Okay. So this whole thing and this whole thing get cancelled. So we are only left with e to the power integral of fx dx dou m by dou y. Is not my dou n1 by dou x is equal to same thing dou m1 by dou y? Yes, it is indeed. So we have proved our claim. Now this proof is important in the coming years, primarily because it tests our understanding of partial derivative and exact differentials. Now I am going to move further and proceed with linear differential equation, and what I am going to do in this one is I am going to find the solution of linear differential equation, and this lecture is primarily focused on its proof. So first of all I will write first order linear differential equation dy by dx plus px, that is p is a function of x, is equal to qx. So our claim was its solution is y into integrating factor is equal to integration of integrating factor into q dx, and our integrating factor was e to the power p dx. This is the claim, and we are going to prove this. This linear differential equation, here degree is 1, and it is not, we are going to today discuss the only first order differential equation. So in today's lecture we are going to solve some more problem after this proof and Bernoulli equation. So the proof for this part has to be, first of all we write in form of mx plus n dy, because we are going to take use of this one. So if we take this py plus q, not q, minus q, this is dx plus dy, because what I have done, py minus q into dx plus dy. So this is of this form. So here m is py minus q, n is 1. So if I take dou m by dou y, it is equal to p, and dou n by dou x is what? 0. So this is not exact, we will like to make it exact. Integrating factor, suppose we want to find out. So first of all, if we take 1 by n, dou m by dou y minus dou n by dou x, okay? So n is 1, this is p, this is 0, so it is p. So p is a function of what? X. So in the earlier proof we have studied that if we do 1 by n dou m by dou y minus dou n by dou x, and that comes out to be a function of x, then that becomes our integrating factor, that is e to the power integral of p dx. Okay, so we have got our integrating factor. Alright, so what we do in multiply, common sense says that we multiply integrating factor thoroughly to this equation, so we will be doing that. So if I multiply e to the power p dx into dy by dx plus py e to the power integral p dx is equal to q e to the power integral p dx, then how we are going to proceed further? We have made it exact, right? So what does it mean? It is a perfect differential by the virtue of integrating factor. So we can see a common sense. And if we take the perfect differential, that is e to the power p dx y. Now for those of you who are wondering as to why I have written it like this, I will just show you. Suppose I keep this as constant, first function, and I take its derivative. Okay. Now I keep y as constant and take this derivative. So e, you know the derivative of e to the power ax, what it is? It is first and then this argument a. Okay, so we are just using the same thing here, nothing else. So how do we do? So first we copy e to the power whatever it is, and then we take the derivative of this argument. So we know the differentiation of integration, that cancel out, that is derivative of antiderivative is a constant function, that the function itself, that means it is p over here. We can write p to avoid the confusion here itself, is equal to this. Take the integral of this. This gives me what? Y into e to the power integral of pf is equal to q p dx. This was our what? Integrating factor. So I can understand that civil services mathematics is all about using formulas, but from where this formulas comes? It comes from the basic fundamental equations, whatever topic you study, whether it's differential equation or vector calculus or fluid dynamics. If you know all of these things very easily, because here the purpose is that you understand the theoretical concept very well, and proofs and derivations may appear sometimes. This is just to have you go through this qualitatively and analyze and appreciate the mathematics involved over here, because this is all class 12th mathematics, and what I have tried to do in this lecture is that I have tried to connect the threads very well. Rather than seeing it through as a different rules and formulas, what I have tried to do is that I have made linkages, the topic, and have taught you in the sequential manner. Now I am left with one topic called Bernoulli Equation. What Bernoulli Equation is, because this equation is also central to examination, because many a times they are asking such kind of questions. So I will just try to